Hello, this is Mr. Stansbury. I'm going to take you through the notes on simultaneous equations. Okay, at the end of this, you should be able to say I can solve a system of equations by graphing, substitution, or elimination. Okay, so first thing, having two equations with two unknowns is called a system of equations. Okay, you can also have three equations and three unknowns, four equations, four unknowns, so forth and so on. But for what we're going to deal with right now, we got two equations, two unknowns is going to be our system of equations. Okay, we are going to solve the simultaneous equations graphically. So basically, we have the two equations, and we're going to solve them. Oops. So when you're solving two equations, basically what they're looking for, let's pretend that this is what our two equations are. When we graph them, that's what they're going to look like. This right here, where they intersect, that's the solution. The intersection is the solution. Okay, and then later on we'll actually see some graphs that actually are curved and may have more than one intersection point. Okay, so anyway, back to this one. We're going to solve these two things graphically. So we basically just want to graph these two things. Okay, so we have x plus 2y equals 8. We could put this into slope-intercept form and graph it that way, or again, we have the x's and the y. This is in standard form, so we can actually just do the x-intercepts, right? So I'm going to try that out. So I know that, sorry, x-intercept and y-intercept. So for this first one here, I know that the x-intercept, here's the x and here's the y. When I'm looking for the x-intercept, that's where it crosses the x-axis. I know that y equals 0. So if I'm looking for the x-intercept, this is gone. And I know that, so I have x plus 2y equals 8. But I know that the y is 0. 2 times 0 is going to leave us with 0. So I know now the x-intercept is actually going to be x equals 8. So I know that this is going to cross here at 8. And then if I'm looking for the y-intercept, that's, oops, this one here. I know all along that line there that x equals 0. So if I have x plus 2y equals 8, I know that my x is 0, so that is now gone. And so now I just have 2y equals 8. Divide by 2, the y-intercept's going to be 4. So those are the 2 points that I'm going to need from my first line. Let's see if I can get this to be a relatively straight line. That looks pretty close. Okay, and then now I'm going to, so I did this one here in red. Let's do this one in green. So now I'm going to solve this one. Y equals 7 minus 2x. We're used to seeing this in slope-intercept form, which would be y equals, we usually see the x first, so negative 2x, and then the 7. And that's plus 7. Oops, not 2, but 7. Okay, so we can actually use this here to just find the, to graph our line as well. So we start at 7, right? There's our y-intercept. And then we go down to over 1, down to over 1, down to over 1, so forth and so on. Okay, so now I'm going to try to get a good line on that there. And that's close enough. And then what we're going to look for is the intersection piece, which is, we can see, is right here. So that intersection point right there is at 2 and 3. Okay, so we have now solved it because we found where those two lines cross. All right, so that is solving graphically. The thing I don't really like about the graphing part is that if it doesn't end up, your solution end up being at a nice easy intersection like that, it's going to be really difficult to figure it out with a graph. So let's look at some other ways to solve these as well. So we're going to solve this one here by substitution. And substitution is, remember, just like what it sounds like. We're going to substitute something in for something else. So on this here, here's what I'm looking for. I've got x equals 3y plus 12. So I know that wherever I see an x, I can substitute in 3y plus 12. So I'm going to put this 3y plus 12 right in for that x there. So I have 3, and now instead of the x, I'm going to substitute 3y plus 12 in. Minus 2y equals 8. And now I'm going to solve this here for y. So 3 times 3y is 9y. 3 times 12 is 36. Minus 2y equals 8. Let's see, 9y minus 2y is 7y. Plus 36 equals 8. Let's subtract 36. We get 7y equals negative 28. Divide by 7, and we get y is negative 4. So that's not our solution, that's just our y value of our solution. So now we've got to figure out what the x is. So if we want to figure out what the x is, we know now y equals negative 4. So now we just plug in y to either, plug in our negative 4 into the y for either one of these equations and figure out what x is. If you'll notice here, this already has x equals, so I'm going to plug it into this one here. So x equals 3 times y, which we now know is negative 4, plus 12. So x is going to equal 3 times negative 4 is negative 12 plus 12. X equals 0. So the intersection point is 0, negative 4. Now, here's a little tricky thing. Don't worry about this unless you're testing. Really, the big thing is when they ask for the solution is just 0. That's when x, you give just the x equals 0 is truly just the solution. They want to know what the x is. They don't really care what the y is. But when we're going through and doing this solve simultaneously, it's nice to have the actual point so that we get a better understanding of what we're actually doing. We're finding the actual point of intersection. Okay? All right. Let's take a look at another one. Now we solved by graphing, we solved by substitution. Now we're going to solve by elimination. And again, elimination is just how it sounds. You're going to eliminate one of the variables. Okay, so what I like to do on these is I like to look for the variable that is going to be easiest to drop out. Like if I look at the y's, I usually look at the bigger of the two and say 5y. Is there something easy I can multiply this negative 3y to get the opposite of 5? No, there's not. So I look at the bigger of these two, again, not even paying attention to the sign, but so the bigger of these two is 4. Is there something nice I can multiply negative 2 by to get to negative 4, which is the opposite of 4? Yes. I can multiply this whole line here by 2, and then that makes this negative 4. So if I multiply that by 2, I got 2 times negative 2 is negative 4. 2 times 5, negative 4x. 2 times 5y is 10y. And then 2 times 4 is 8. Don't forget to distribute through to all three. I will often see people that will forget to distribute it to this last piece on the other side of the equation as well. Okay. Now we're going to bring this other equation down here. 4x minus 3y equals 6. And now when we add these two lines together, we eliminate the x's because that turns into 0. 10y minus 3y is 7y. 8 plus 6 is 14. Divide by 7. And we found that y is 2. Okay, so for our solution, we now know that y is 2. Okay, now we got to figure out what the x is. So we're going to plug y into either one of these two equations and figure out what the x is. I'm going to plug it into this one here because my x is already positive. But either way will work just fine. 4x minus 3 times y, which we now know is 2, needs to equal 6. 4x minus 6 equals 6. Solve this thing here. We add 6 to both sides. 4x equals 12. Divide by 4, both sides. And we get x equals 3. So the solution is 3, 2. Okay, that's the point where these two lines are going to intersect. All right. 2 more examples here. Example 12, solved by elimination. So this one here, I look at the 3. Is there something nice I can multiply 2 by to get to the opposite of 3? Not really. Is there something, I look at the 5 as the bigger of the 2. Is there something nice to multiply 2 by to get to negative 5? Neither one has a nice one. So on this one, you just got to pick one and go with it. I'm going to do this one here. So I'm going to multiply this top one. So I've got 3. So I have 3. And I want to get 2 times some number. Let's call it A. 2 times some number to get to the opposite of 3. So divide both sides by 2. A is going to be 1.5. So I have to multiply by 1.5 to get it to equal 3, but I don't want it to equal 3. I want it to equal -3. So I have to multiply this whole thing by -1.5. Okay? So -1.5 times 2 is -3x. Half of 1.5 of 5 is going to be -7.5. And then -1.5 times 20 is going to give us -30. And now we add these together. Those get eliminated. 2y minus 7.5y, is -5.5y equals -11. Divide by -5.5. And we're going to get that y equals 2. Okay? So again, we found the y. So now we have to plug the y back into either one of those to get the x. I like this one here just because it's 2 instead of 3. 2x. So 2x plus 5 times 2 equals 20. 2x plus 10 equals 20. Subtract 10 from both sides. 2x is 10. So we divide both sides by 2 and we get x is 5. Okay, so our solution to this thing here is 2, 5. That is our solution.